bridge rectifier is. So we're gonna do this one example and then we will take a break. So this one would be on the bridge rectifier. So you should get 15.57. What are the VP for the VP count? And the PIV should be 16.27 volts. So if you carefully read the problem, the secondary voltage is already given to you. So it says 12 volts RMS is noted on the secondary voltage for a 120 volt standard transformer. So that's 12 volts RMS is the secondary voltage, but the only thing you need to do is make sure you convert into the peak voltage. So I think it's like 16.97 volts peak, right? So, and then you look at what the problem is asking for. So this one is the peak bridge rectifier asking for peak output voltage. So it's whatever the peak secondary voltage is and you take away 1.4 from it. So it would be 15.57 volts peak. So that would be the peak output voltage. So this, the first thing you would do is calculate the peak conversion. So that would be your output voltage. And the next problem is asking is the PIV rating. So according to the bridge rectifier, it's the peak output voltage added with 0.7. So that would be 15.57 added with 0.7 volts. So that would be your 16.27 volts. It's the PIV for it. So the signal shape, if it asks for again what shape of the signal we are expecting. This is the full wave. Bridge means it's a full wave rectifier. And the peak voltage should be how much? 15.57, which is the peak output voltage. So that's the maximum voltage, the peak voltage that we will be looking at on this full wave bridge. What? What is 2 hours? No. When we went for a break last time. That's what you're saying? It's been 2 hours? You're saying you want to do 2 more or what? Half an. Pardon, yes. That's only on the secondary side. The 16.97 is only the secondary voltage, which is before the rectifier, before the diode side of it. 16.97 is before the bridge, after the transformer. So right here. What I'm trying to say is it's 16.97. Yeah, right there. Right. It's going to hit that diode at That is true. Yeah. Because this point.
But that diode's not rated to hit 1697.
Both those diodes each drop 0.7.
Yeah, according to this one, so we may need to raise it pretty much.
So it needs to be higher than
Yeah,
16.
the rated diode, the rating should be higher. So we may need to increase the rating of the diode pretty much.
So that this shouldn't be the way. We need a new way to calculate the PIV then.
Again, that's not the breakdown itself. If you see what I mean. PIV is not the breakdown voltage. It's according to the given configuration, whatever the reverse voltage it can block. But we need to choose, it should be at least higher than the actual rating of the diode.
You would think it would need to be higher than this.
Yeah. So if then we purchase it, we purchase those diodes with a little bit higher breakdown voltage. So let me show it to you the data sheet again. Usually diodes, if you pick like 50 volts PIV, again this PIV rating is for that given circuit only. If you change anything of it, the PIV will change it. But when you're actually purchasing it, we need to make sure that whatever that rated value should be larger than what this can hold it. Because this is the voltage that the diode sees it when it is reverse bias. Like you mentioned, that diode that is already reverse bias, that's the voltage it sees it. So that diode that you just showed me, right, the one reverse bias, that diode sees 16.27.
Okay.
But we don't know what its rated voltage is. When we buy it, we know what the actual rated voltage is, as if their breakdown. Yes, what I'm saying?
Okay.
So this 16.427 is only indicating that this is the voltage a reverse biased diode will see. That's the voltage it will actually see it. But can it handle it? Can it handle it or not? That's another. That's where we pick the rated value a little bit higher.
Yeah, it says that the diodes will be 20% higher than the PIV.
Yeah, if it's available. Usually diodes 50, 100 volts like that. So if you choose a 50 volts diode like we use, like the one we use in the last class, it can safely handle this. But if you choose a diode has a breakdown of, let's say, 10 volts, then it's not going to handle this. All right, so are we clear? But just be careful. Some problems you will see the secondary voltage will be given it to you, like in this one. So you don't need to calculate. But if it's not given, then you will see turns ratio. In this problem as well, you don't see the turns ratio, correct? So that's the one way to tell is probably something is already given. So, yeah. Again, the sole purpose of the transformer is only to step down. It doesn't do any rectification. The signal has to pass through diodes to become DC. Again, transformer is only AC to AC, not AC to DC, but whereas the diodes are.